Class 2 Natural Resources, their sustainable management and conservation. Natural resources vary greatly in their location, quantity, and quality. For instance, a particular forest type may occur only in certain countries. Also, the geographical area covered by forest and wood quality may differ widely in different countries. Some resources can be reused after being used once. A convenient classification of resources is based upon their exhaustibility and renewability. Basically, natural resources can be characterized as inexhaustible and exhaustible. 1. Inexhaustible resources. Inexhaustible resources are available in unlimited quantities on the earth, while some inexhaustible resources remain virtually unaffected by human impact. Many others may show some changes in their quality, though their quantity may remain unchanged. Resources like solar energy, wind power, tide power, rainfall, and even atomic energy cannot be exhausted significantly at global level due to human activities. Some resources may sometimes be locally affected by human activities. For example, pollution may change the quality of air. Second, exhaustible resources. A large number of natural resources are exhaustible. That is, they have finite supply on the earth and can be exhausted if used indiscriminately. Broadly, the exhaustible resources can be either renewable or non-renewable. Renewable resources. Most of biotic resources are renewable. The growth and reproduction of such resources can be successfully managed so that these resources are continuously regenerated. However, if the consumption of these resources continues to exceed their rate of renewal, not only their quality becomes affected, but they may also even get totally exhausted. Selected examples of ecosystems and their important renewable products are forests, which yield timber and other plant products; rangelands, which sustain grazing animals for milk, meat, and wool production; wildlife, which maintain food chain; agriculture systems, which yield food and fiber; marine and freshwater systems, which yield various foods from plants and animals; soil and water are other renewable resources. Non-renewable resources. Some biotic resources are non-renewable, that is, they cannot be regained or reconstructed once they are used up. Biological species, which have evolved in nature during the course millions of years, are considered non-renewable. Once a biological species becomes extinct from the earth, it cannot be recreated by man. Many abiotic resources are also non-renewable. For instance, fossil fuels and metals, once once extracted cannot be regenerated at the place of extraction. After unlimited extraction and use, the fossil fuels will certainly get exhausted. Next, principal natural resources. Among the earth resources, the following contribute significantly to human welfare. 1. Forest, water, minerals, food, energy, land, wetland, grasslands. First, forest resources. Approximately one-third of the Earth's total land area is covered by tree species dominated communities called forests. The forests are storehouse of biodiversity and provide important environmental services to mankind. Current data as per India State of Forest Report 2019. The total forest and tree cover is 24.56% of the geographical area of the country. The total forest cover is 7,12,249 square kilometers, which is 21.67% of the geographical area of the country. The tree cover is 2.89% of the geographical area of the country. The top 5 states in terms of increase in forest cover: Karnataka, Andhra Pradesh, Kerala, Jammu and Kashmir, Himachal Pradesh. These services originate from the following key functions of forests. Productive functions include production of wood, fruits, and a wide variety of compounds such as resin, alkaloids, essential oils, latex, pharmaceuticals, etc. Protective functions include conversion of soil and water, preventing drought, sheltering against wind, cold, radiation, noise, sights and smells, etc. Regulative functions involve absorption, storage, and release of gases, water, mineral elements, and radiant energy. Such regulative functions improve atmospheric and temperature conditions and enhance the environment value of the landscape. Forests effectively regulate floods and drought and the global biogeochemical cycles, particularly of carbon. Forest conservation and management. Forest conservation and management programs should ensure sustainable supply of tree products and services to people and industry, and maintenance of long-term ecological balance through protection, restoration, and conservation of forest cover. Extensive planting of trees through afforestation programs is needed to save diminishing forest cover. To achieve these goals, the following forestry practices should be carefully integrated. Protection or conservation forestry. It involves protection of degraded forests to allow recoupment of their flora and fauna. Well-stocked forests are managed scientifically for providing timber and other forest products without causing any negative environmental impact on the forest. Forest areas designated as natural parks and sanctuaries are protected from human interference. Production or commercial forestry. On the other hand, production or commercial forestry aims to fulfill the commercial demand without causing denudation of natural forest. Through intensive plantation is available land, production plantation of fast growing trees are raised using modern forestry techniques. Next, social forestry and agroforestry. These programs are also included in this category. Social forestry aims to plant trees and shrubs on all unused and fallow land to provide fuel wood, fodder, etc., thereby reducing pressure on existing forests. For example, unused farmlands, community land, road and rail slides, etc., are planted with suitable indigenous and exotic tree species. Agroforestry includes a variety of land uses where woody species are grown in combination with herbaceous crops either at the same time or in time sequence. For instance, Tuangia system involves growing agriculture crops between rows of plant trees. The well-known shifting cultivation or zoom, an agroforestry system widely practiced in the northeastern region of our country, involves felling and burning of forests, following by cultivation of crops for few years and abandoning cultivation to allow forest regrowth. Water resources. About three-fourths of the Earth's surface is occupied by oceans, which contain about 97% of the Earth's water in strongly saline condition. The rest 3% is fresh water, and all of this is not available for direct human use. Water use on global basis. The water use has increased 4 to 8% per year since 1950. The consumption rate varies among countries. Distribution of water. Earth's water 97% saline, 3% fresh water. Fresh water 68.7% ice caps and glaciers, 30.1% groundwater, 0.9% other, and 0.3% surface water. Freshwater surface fresh surface water liquid 87% lakes, 7% 11% swamps, 2% rivers. Worldwide, approximately 70% of total water use is accounted by agriculture. Only about 10% is used for domestic and municipal supplies, and the rest is consumed by various industries such as cement, mining, pharmaceutical, detergent, and leather industries, etc. In India, since independence, availability of water has declined by two-thirds. The water requirement of major water-consuming industries such as agriculture, refineries, petrochemical, fertilizers, and chemicals has grown 40 times. It is estimated that water demand in agriculture sector will increase twofold in 2025 compared to the demand in 1990. Problems. About 40% of world's population lives in arid or semi-arid regions. These populations spend substantial amount of time, energy and effort in obtaining water for their domestic and agriculture use. To meet the needs of the huge population, surface water are overdrawn. Due to the overuse of surface water, the nearby wetlands may dry up. When more groundwater is removed from human use than can be recharged by rainfall or snowmelt, the groundwater may also dry out. Excessive irrigation in semi-arid and arid regions can cause salt accumulation in soil, due to which crop productivity may decline. The continuous depletion of groundwater along the coastal regions often leads to the movement of saline seawater into freshwater wells, spoiling their water quality. Estuaries became more saline and consequently less productive when surface waters are overdrawn. Heavy rainfall results in rapid runoff from areas having the exposed soil, particularly on mountain slopes. This is not only causes soil erosion but puts lowland areas at extreme risk of destruction due to flooding. Uncontrolled soil erosion results in sedimentation of waterways that can harm fisheries. Conservation and management of water. Main approaches for conservation of water are reducing agriculture water wastage by increasing efficiency of irrigation. By the traditional method of irrigation, plants absorb less than 50% of water applied to the soil. The rest is lost. Reducing water wastage in industry by recycling the used water. Reducing domestic water wastage by constructing wastewater treatment plants and recycling the treated water. Rainwater harvesting by employing practices to store rainwater and recharge groundwater. Afforestation and protection of watersheds to improve water economy. Some important water management approaches to provide a sustainable supply of high quality water are construction of dams and reservoirs to ensure year-round supply of water, and in addition controlling floods and generating electricity. Desalination of seawater and saline groundwater, making it fit for drinking and other purposes. Diversion of water bodies to increase the natural supply of water to a particular area. Regular dredging and desalination of water bodies. Third one, mineral resources. Minerals essential to our industrialized society and daily life are non-renewable resources. Due to the increase in industrialization, the consumption of minerals has increased tremendously all over the world. The minerals now in short supply will probably be exhausted within next 20 to 100 years. Even the minerals which are relatively plentiful, example iron and aluminium, will become extremely expensive because of the depletion of large, rich, and easily accessible deposits of these metals. Minerals can be metallic, example iron, copper, gold, etc., or non-metallic, example sand, stone, salt, phosphorus, phosphates, etc. Problems: extraction, processing, and disposal of minerals have negative effects on environment. Mining not only disturbs and damages the land but also pollutes the soil, water, air. The land that has been destroyed due to mining is known as derelict land or mine spoil. Such derelict lands can be reclaimed or restored to a semi-natural condition by revegetation to prevent further degradation and to make the land productive for other purpose. Conservation of minerals. Mineral conservation measures involve their recycling and reuse. In recycling, used and discarded items are collected, remelted, and reprocessed into new products. Example iron scraps, aluminum cans, etc. Some minerals present in products can be recycled: gold, lead, nickel, steel, copper, aluminum, silver, zinc, etc. However, minerals in other products are lost through normal use, such as paints containing lead, zinc, or chromium. During reuse, used products are collected and used over and over again. Example reuse of glass bottles. The benefits of reuse are greater than those of recycling. All products, however, may not be reused. Recycling and reusing not only renew the mineral resources but also help in saving unspoiled land from the disruption of mining, reducing the amount of solid waste that must be deposited, and reducing energy consumption and pollution. Next, fourth, food resources. It is estimated that one or more plants of about 30,000 plant species can be eaten by people. However, interestingly, only 15 plants and 8 animal species supply as much as 90% of food eaten by us. In fact, only 4 crops, namely wheat, rice, corn, and potato, together account for more than world's total food production than all other crops combined. Two-thirds of the world human population survives on a diet of grains, mainly rice, wheat, and corn. Perhaps this large fraction of population cannot afford meat products. With rise in income due to the development, the grain consumption generally increases because people consume more of meat, eggs, and milk produced by grain-eating livestock. Next, energy resources. Future energy needs of rapidly expanding human population will demand the exploitation of most energy sources. Broadly, energy resources can be recognized as non-renewable or renewable. Non-renewable energy sources include various fossil fuels and nuclear energy. Fossil fuels include petroleum products, natural gas, and coal. Nuclear energy is mainly obtained from the nuclear fission of the uranium. The world reserves of the fossil fuels and uranium are limited and will eventually be depleted. Burning fossil fuels for energy has 17 negative environmental consequences such as global warming, air pollution, acid rain, and oil spills. It has been necessary to minimize use of non-renewable energy resources and to replace them with renewable resources. Renewable energy resources are regenerated by natural processes so that they can be used indefinitely. Renewable energy generally causes much less negative environmental impact than fossil fuels on nuclear energy. With the current state of technology, the generation of renewable energy is often more expensive than energy produced by fossil fuels out nuclear energy. However, with the technological advances, the cost of renewable energy is expected to decrease. Among the renewable energy sources, the most important one is solar energy. The other renewable energy resources are hydropower, wind, geothermal energy, ocean waves, and tidal energy. 1. Solar energy. Solar energy can be used directly or indirectly for human welfare. Direct solar energy is a radiant energy, whereas indirect solar energy is energy obtained from materials that have previously incorporated the sun's radiant energy. Energy plantations. Energy plantation of plant species showing high calorific value and growth rate are raised in selected areas to produce biomass. Hydropower. Water falling from a height turns turbines at the bottom of dams to generate electricity. Hydropower produces approximately one-fourth of the world's electricity and is usually cheaper than electricity produced by thermal power plants. However, building a dam to hold the water leads to several environmental problems. Example, submergence of plant and animal habitats and displacement of people. Wind energy. When fans are rotated by action of winds, its energy can be used for generation of electricity. However, harvesting wind energy is possible only in areas that receive fairly continual winds such as islands, coastal areas and mountain passes. Fifth, tidal energy. The difference in the level of water between high tide and low tide can be used to generate electricity. Geothermal energy. Heated groundwater flowing upwards as hot water or steam or as hot springs can be used to turn turbines and generate electricity in geothermal power plants. Ocean wave energy. Ocean waves produced by winds have the potential to turn a turbine and generate electricity. Land resources. Earth's one-fourth area is formed by land which is largely covered with natural forests, grasslands, wetlands, and man-made urban and rural settlements, along with agriculture. Low-lying areas covered with shallow water are called wetlands. The wetlands are transitional between terrestrial and aquatic areas. Soil is the upper weathered crust of earth which supports plant growth. In all land resources, soil is of critical importance. Estimates indicate that over 50% of land area in India suffers from soil degradation. Soil erosion. Movement of water and air removes topsoil from the land by process of erosion. Abundant plant cover significantly reduces soil erosion. Human activities accelerate soil erosion by removing natural plant cover. Depletion of soil fertility. When natural vegetation is removed to develop agriculture systems, as has happened in most parts of India and indeed in the world, not only the nutrients stored in vegetation are removed, the organic matter and nutrients accumulated in the soil are also lost. Soil conservation. Several soil and crop management practices can minimize erosion and reduce nutrient depletion of agriculture soils. These include practices like conservation tillage, organic farming, crop rotation, counter ploughing, and strip cropping terraces. In contrast to conventional tillage, con- con- conservational tillage incorporates residues from previous crops into the soil, thereby increasing the organic matter, which in turn improves soil moisture and nutrients. Reduced tillage and no tillage are two kinds of conservation tillage. Efforts of efforts to improve erosion affected soil involve two steps: stabilizing the soil to prevent further erosion and restoring the soil fertility. Soil stabilization will need seeding of bare ground with plants that can survive harsh conditions. Example, drought resistant grasses. Such plants eventually establish vegetation cover on the soil, preventing further erosion. With increasing addition of detritus, the soil organic matter, nutrient, and moisture levels improve. The restoration of soil fertility to its original level is a slow process. Application of biofertilizers is useful in enhancing soil fertility. Various organic farming measures which provide increased organic input to soil have long-term beneficial effects on soil fertility. Next, grasslands. Grasslands provide forage and habitat to domestic animals and wildlife. In rural areas, dried hay removed from the grasslands, particularly from tall grasses, is also used as fuel or trenching material. Grass cover is extremely effective in binding soil particles with the help of highly branched fibrous root system, thereby significantly reducing soil erosion. In India, the area under various kinds of grass cover, including fallow and wasteland, is estimated to be about 18% of total land area. Degradation of grassland. Degradation or destruction of grassland is mainly related to overpopulation. To enhance food production, grassland processing fertile soils are plowed and converted to agriculture lands. In developing countries, grassland areas are frequently overgrazed. For example, the number of animals grazing in the arid and semi-arid regions of India has been found to be 2 to 10 times greater than the capacity of grasslands to feed the animals. The lack of point covers the due to overgrazing causes soil erosion due to water and wind. When overgrazing occurs in combination with extended periods of drought, once fertile grassland can be converted to a desert. The conversion of grassland to desert is called desertification. Grassland management. Frequently employed measures of grassland management are outlined below. Protection from grazing to allow recovery of severely damaged vegetation. Use of rotational grazing while some areas are closer to grazing, allowing the plant cover to recover. Grazing is permitted in other selected areas. Removal of woody bushes or shrubs and weeds which usually adversely affect the productivity of grasses. Conversional conservation of soil and water by reducing loss of soil and water from the grassland. Use of controlled burning to promote recycling of nutrients stored in dead mulch and to reduce woody species inversion. Next, wetlands. Wetlands are low-lying areas usually covered by shallow water and have characteristic soils and water-tolerant vegetation. Wetlands may be either freshwater or saltwater. Freshwater wetlands include marshes, swamps, and periodically flooded riverine forests found in lowland along streams. Wetland conservation. Programs for conservation of wetlands generally employ the management approaches listed below. preparation of wetlands inventories, identification of wetlands of critical importance for their protection, checking waste deposits in wasteland, reduction of excessive inflow of nutrients and silt into wetlands from surrounding uplands by keeping them under plant cover. Natural resources. Natural resources, especially water and soil, are essential for the function and structure of agriculture production systems and for the overall social and environmental sustainability. Agriculture accounts for roughly 70% of total freshwater withdrawals globally. Farming also contributes to water pollution from nutrient and pesticide runoff and soil erosion. Without improved efficiency measures, agriculture water consumption is expected to rise by about 20% globally by 2050. Climate change is already affecting water supply and agriculture through changes in the seasonal timing of rainfall and snowpack melt, as well as with the higher occurrence and severity of drought and floods. One third of the planet's land is severely degraded and fertile soil is being lost at the rate of 24 billion tons a year as a consequence of bad farming practices such as heavy tillage, multiple sequential harvests, and abundant use of agrochemicals. An increase of productivity can help push progress towards future food security and the general well-being of producers and rural community uh, globally, but given the limited natural resources based on which agriculture depend, sustainable development will ultimately depend on the responsible management of the planet's natural resources. Good practices to help reduce agriculture pressure on natural resources and build more efficient and resilient production systems. Crop rotation can help to manage your soil and fertility, reduce erosion, improve your soil's health, and increase nutrients available for crops. Sustainable use of natural resources includes particles that practices that encourage the protection and restoration of water sources and promote water use optimization, require the implementation of systems for wastewater treatment before reuse or disposal, foster soil conservation and improved carbon stocks, promote waste reduction, recycling and responsible disposal. Solution for implementation of sustainable management systems that allow implementation of functional social and environmental management systems that can be adapted to the specific characteristics of each productive landscape. Responsible management of service providers to reduce the indirect impact on ecosystems and natural resources. Increased productivity through an optimization of resource use and implementation of mechanisms to facilitate traceability and implementation of functional social and environmental management systems that can be adapted to the specific characteristics of each productive landscape, implementation of mechanisms to facilitate traceability and integrity of agriculture and livestock products.